When light interacts with an object, it can do one of two things. Either it can bounce off the object and directly bring back information like colours, or it can get absorbed by the object, which might not bring back information directly, but the information that doesn't come back creates darkness, which can imply information about the object. In the same way all matter is made out of atoms, all light is made out of photons. A photon is the smallest indivisible unit of light. Or in other words, it is a quanta of the electromagnetic spectrum. I'll explain what a quanta is in a minute. The electromagnetic spectrum shows us how much photons vary in size, on a spectrum from infinitely small to infinitely big. This is important because a photon cannot interact with an object smaller than it. A photon 1 millimeter cannot interact with anything smaller than 1 millimeter, the same as a photon 1 trillionth of a meter cannot interact with anything smaller than a trillionth of a meter. Basically, the smaller the object is, the smaller the photon needs to be in order to observe it. Glass, for example, is see-through to visible light because the photons, as Eminem says,
I'm just too big to respond to it.
With it being the glass's molecules. So the photon travels straight through and brings back information from the other side. This same phenomenon can be seen with X-ray scans, which work by shooting a bunch of X-rays at someone and recording the ones that hit the wall behind them. The X-rays travel straight through the person's soft organs, partially through the person's not-so-soft muscles, and not at all through the person's dense bones. This can allow us to see a person's skeleton without cutting them open. The problem is that all photons contain the same amount of energy. In other words, the smaller the photon is, the more densely packed the energy becomes. The difference between a 1 meter radio wave and a 1 micrometer microwave is the microwave has the same amount of energy contained with 1 millionth the space as the radio wave. Or in other words, despite the energy contained within both photons being the same amount, the microwave is 1 million times more energetic than the radio wave. Quantum mechanics deals with quantas, which are the smallest indivisible units of things. So quantum physics deals with the smallest indivisible units of physics. Or in other words, the objects they study are really, extremely, ridiculously small objects. Likewise, these objects need really, ridiculously small photons to observe. The problem is, at those sizes, the photons they use are so energetic they can physically move the objects they are observing. This is a problem because it makes observations about the object's position to no longer be accurate. If they want to observe an object they are studying, they need to cut back on the image quality. At that scale, you can predict how inaccurate an observation recorded is because the clearer the observation, the more the photon making the observation would have moved the object. Given how interested you must be in the electromagnetic force for looking up the definition for such an obscurely technical term and not because I had a cool name or anything, I recommend looking up a Kugelblitz black hole, which are lights so bright that not even light can escape.